Our Sudoku game is well underway, but it still has some major problems we need to fix before moving forward. Stay tuned because we'll be fixing all of them in this video. Hello everyone, my name is Mike and you're watching Polymath Unlimited. In this series we are learning the C++ programming language by building our own Sudoku game. So far we have implemented all of the game logic, we have written an autosave feature, and we have implemented a file directory to allow the user to make their own saved games. However, there are three glaring issues that we will address in this video. Firstly, when the user runs the list saves command, we are using system pause to prevent the screen from clearing immediately after the saved games are listed. This works okay, but if you're running on a Unix system, you might have noticed that the list saves command doesn't appear to work. This is because the pause command is a Windows command, so it won't work on Unix. So in order to make our code portable to Unix systems, we need to find a workaround. The second and most severe issue is that the autosave feature and file directory only works if the user physically runs the exit command in our game's terminal. If the user forces the program to terminate by some other means, like pressing X or Alt F4, then our autosave won't get saved, and even worse, any saved games that the user has created during that session won't get recorded in the file directory. So we need to find a way to have those files save even if the program exits unexpectedly. Finally, our file directory can only hold 1,000 saved games. It might seem a bit ridiculous to want more saved games than that, but just in case, it would be nice to be able to have more than that. We could simply make our saved games array larger, but that would unnecessarily increase the amount of memory that our program uses. It would be nice to have a way to resize the saved games array while our program runs. That way we don't have to worry about having more saved games than the array can hold. It turns out that all of those problems have relatively straightforward solutions. We'll solve the system pause issue first. When we write text to the console, we use the built-in cout object from the IOStream library. The arrows next to cout indicate that we are streaming data into the cout object, which then streams that data into the console so the user can see it. You might notice that cout is not the only stream object we commonly use. For example, fstream objects are stream objects that allow us to stream data to or from files. So what if, instead of streaming data to the console or a file, we could stream it to a string variable instead? That way, our program can access the streamed data later. It turns out that C++ has a very convenient library called sstream that allows us to do just that. Let's include sstream in our program. Now at the beginning of the main function, let's declare a string stream object. We'll call this object console because it will represent data from the current iteration of the game loop that we want to stream to the console in future iterations of the game loop. Now in the game loop, we can just replace all the cout references with our console object and get rid of any system pause commands. This will place any data we want to stream to the console on the next loop iteration into our stream object. Now we can simply use cout to write the contents of the string stream object to the console. Note that we also need to clear the contents of the string stream after we display it, so that way we don't keep printing old, outdated data. If we run our program now, we can see that it works perfectly fine without the system pause command, because commands like list saves write to the string stream instead of to the console, and then the contents of the string stream just get printed to the console the next time the game loop runs. Now let's turn our attention to our biggest problem, fixing our autosave and file directory. When we exit the program externally, for example by pressing X or typing Alt F4, our computer's operating system sends our program a signal telling it that it should exit as soon as possible. So what we need to do is find some way of writing code that will execute when one of those signals is detected. That way we can ensure that all of the files we want to write are actually saved before the program terminates. We can do this using the csignal library. This library includes functionality for detecting signals and responding to them. In order to respond to signals, we need some kind of signal handler in our program. For compatibility reasons, our signal handler needs to be a void function that accepts a single integer argument. Let's add a void function called signal handler that accepts an integer called signal. We'll leave this function blank for now, but any code we want to run when we detect our exit signal will go here in a moment. Now, to use our signal handler, we need to register it using the signal function, which is included in the csignal library. There are 3 signals that we will register our signal handler for: sigint, sigterm, and sigbreak. Sigbreak is a Windows-specific signal, so we'll only use that if Win32 is defined. These 3 signals should cover most of the instances where the program is forced to exit externally. If any kill signals are sent, then our signal handler will get executed before the program exits. If we test this by writing to a file called exittest.txt in our signal handler, we can see that if we run the program, then exit by pressing X, then our signal handler did in fact get executed before the program terminated. Now we can simply copy all of the code from our game loop's exit command into our signal handler. Notice, however, that since our board state and our file directory are within the scope of the main function, they are inaccessible to our signal handler. We can solve this by moving them outside the main function and into the global scope. Usually it's not a good idea to use global variables in this manner, since things can quickly get very messy and hard to debug. While there are technically ways around using global variables in this case, they are all more complex than this situation calls for. So in this simple program, we are probably fine to use them here. Just make sure that if you do use any global variables in your programs, it is always for a good reason and you manage them responsibly. Now that our file system is working correctly, let's fix our saved games array so we can resize it if we want to add more saved games to it. We can do this with dynamic memory allocation using pointers. We briefly mentioned pointers in a previous video, but we'll be going more in depth on the subject here. We can declare a pointer by using an asterisk after the variable type. Let's turn our saved games array into a string pointer. This means that instead of holding data, our saved games variable will contain an address in our computer's memory. This memory address will be the location at which our list of saved games lives in memory. We'll initialize this pointer to null since we have not yet allocated any memory to it. In order to allocate memory, we need to use the new keyword. When we load the file directory in the main function, we'll use the new keyword to allocate memory to our saved games pointer. We specify the amount of memory we need between square brackets after the data type. One important thing to note here is that since we have manually allocated this memory, we also need to manually deallocate it before our program exits. For example, at the end of the main function. We can do this with the delete keyword. It's also usually good practice to check if a pointer is valid before deleting it, and to invalidate it after deleting it by setting it to null. Let's also deallocate the memory in the same manner at the end of our signal handler, since the main function won't technically finish if the signal handler is ever called. Once the memory has been allocated, our saved games pointer can be used in our program the exact same way as an array would be. Nothing in our code needs to change here. In our save command, it is now relatively straightforward to resize the saved games array to hold more saved games. First, we need a temporary pointer to hold the current contents of the directory. So we'll create a new string pointer called temp and allocate memory to it. Then copy the contents of the saved games array to it. Next, we need to deallocate saved games, then reallocate it with more memory than it had before. Next, we simply copy from temp back into saved games, then deallocate the temp pointer. With all of these fixes in place, we are finally ready to move on to adding more features to our game. In the next video, we'll add some code that will allow our program to automatically solve a Sudoku board. This will provide the foundation for all sorts of neat features that we might want to add, like giving hints to the user, letting the user cheat and see the solution, and even eventually having our program generate its own randomized Sudoku puzzles. Until then, feel free to play around with this program and see what features you might want to add to your own version of it. Make sure to share your progress and ideas down in the comments. Thank you for watching, and I will see you next time.